Okay. Welcome back from coffee or virtual coffee break, everyone. Next up, we have Maarten Balliauw, another person in flames. Flaming person.
On fire.
On fire, yes.
This is awkward.
Maarten is also one of the returning speakers to IglooConf and other conferences that we've had. So welcome back, Maarten.
Thank you.
Excellent. Let's give him a round of applause.
All right, thank you everyone, and welcome from my side as well. I do want to stress before we start that during the breaks, please talk to the speakers, because we're here to share knowledge and so on. We want to talk to you as well, learn what you are facing and whatever you are doing day to day, and see if we can get something out of that as well. Do be aware, there's two Maartens here, and it's pronounced the same. And it's super annoying, because every single time someone mentions one of our names, we both look up. So that's Maarten, I'm Maarten. If you really want to mess with us during the breaks or whatever, just say our name and we'll both look up and be confused. Yeah, you can't tell us apart, that's the thing. So there's that, and yeah, do talk to us, because who knows, maybe we smile back. All right, let's talk about Azure Functions and indexing NuGet on Azure Functions. And what I want to start with is the story on how we started building something on Azure Functions to index things that are on NuGet and so on. So is any one of you using Rider or ReSharper from JetBrains? Okay, cool. Has anyone used the Find This Type on NuGet feature in there? Okay, one person, cool. That's actually a very nice feature, because it allows you to write code, and whenever you are using a type that is not yet referenced in a NuGet package, for example, we will show you this quick fix where you can find this type on NuGet.org, and it will install the package into your project or solution, reference it, and make sure your code compiles and you can continue working. So really, really useful to do that. That feature actually was introduced in ReSharper 9 in 2015, I think. The actual idea for that feature originated in Finland. We had a company party at JetBrains somewhere in 2013, which was in Lappeenranta, I think. And we were chatting with a couple of guys on the ReSharper team, like, look, we should have this feature. So we started building that, and finally in 2015 we had it live. And I think Visual Studio also added something similar in 2017. Now, if you start thinking about this feature, you will see that you will need a couple of things. First of all, there's of course the thing that you have in ReSharper and Rider. You want to have that quick fix. You want to have an analyzer looking over your code and checking whether something can be installed or not. But you also need some data store that tells you which NuGet packages are available and which types are available in all of those NuGet packages. And back then, in 2015, we built this out as an Azure Cloud Service. Anyone used Azure Cloud Services? Anyone still using Azure Cloud Services? Yes, they are awesome. They are underrated, but they are awesome. So it's running on that, a web role for the web API that we use in ReSharper, and a worker role on the back end, which does all of the indexing and crawling of whatever is available on NuGet.org. Now, this indexer makes use of the NuGet OData feed, and I'll quickly show you what that beast looks like. The NuGet OData feed is a big bunch of XML that you can address over OData. And what you can do is go to NuGet.org/API v2 packages and then write a select, which is basically give me this view on the data that you have, and then order by last edited, for example, to just get the latest packages that have been added to NuGet.org. Anyone used OData or still using OData? A couple of people. That was GraphQL before it was hip. Right, so we have this thing, and if you load it, you will see that all of the data that is in there, once we render, will be XML-based, and you will have, this takes a long time, you will have a number of entries that are in there. Every entry has an ID, every entry has a category. There's a link to the actual package that you can download. The author information is in there, as well as a number of properties like the package ID, package version, etc., etc. So quite easy for us to parse. and also quite easy for us to page over that entire stream of OData. If you look at the bottom of that OData feed, you will see that there's a link to the next page. So if we click that, we simply get the next page of results, and we can start crawling that as well. So if you just follow all those links, we can index all of the NuGet packages that are available on NuGet. Let's go back to slides. There we go. Now, NuGet over time, and this was a tweet from somewhere end of 2018. Back then, NuGet was 1.9 terabytes in size, whereas in 2015, when we started with this thing, it was only 250 gigabytes. So this is the disk in one of the worker roles that we have there. So NuGet has been growing. That's interesting, because there's only a certain amount of disk space that you can have on Azure Azure Cloud Services in a web and worker role. So we have to be careful that we don't exceed that disk size to be able to keep doing what we do there. Also, NuGet over time has been introducing a couple of new features. Somewhere last year, they introduced repository signing. Well, actually last year, so 2018, they introduced repo signing. And basically what that does is it adds a digital signature to every NuGet package that is available on NuGet.org. Now, what happens is if they change a package on NuGet.org, that also means the entry is updated in the database, which also means that the entry is updated in that OData feed, which also means that we have to re-download every single package that is in NuGet.org at this time. So basically, we had a very long queue in our indexing process because of this operation that they did. We had to re-index everything that was on there. Also, these OData feeds, they are nice if you can get just a couple of pages. Say, I want the packages for the last 2 hours. That's just a couple of pages. But the deeper you go, the more pages you get from that OData feed, the slower that thing becomes. So that's also not nice. Another thing that we saw is that the OData API is actually going to be deprecated pretty soon. So we had to rethink what we were building and rethink what we were doing and think of a better way of getting that data and accessing whatever packages and whatever types are available on NuGet.org. So yeah, a couple of big warning signs for us to start thinking about, maybe we should do something else. And we started doing that. But before we dive into that, I quickly want to talk about the new NuGet server-side API. So you already saw that we had that V2 API, which is OData-based. NuGet can also work with a file system. So if we would download all of the NuGet packages to disk, we could use it from disk and work with that. Or we could make use of the new V3 JSON-based APIs that are available. The V2 APIs, as I mentioned, they start to get pretty slow if you page over a lot of pages, so we didn't really want to dive into those too much and reuse those in a new solution that we were to build. We did want to go for the V3 protocol that NuGet has. The V3 protocol is JSON-based, and it's sort of a resource provider. So if you go to the actual API, index.json there, you will see that that's just a file that contains links to other APIs. It's a resource document describing which resources are available and where they live. You will see in this document that there's a resource for the catalog, which is an append-only event log of everything that happens on NuGet.org in terms of packages. There's package registrations that are used to render details inside of Visual Studio and ReSharper and so on. There's a flat container, which is used during package restore. There's some templates in there to report or to rate packages and so on. There's statistics in there. There's really a lot of resources in that index.json file. For us, that catalog seemed actually quite interesting, because that catalog is what powers NuGet pretty much. If you upload a package to NuGet.org, what will happen is that they will add the data into their database, but they will also add that data into that catalog. They will simply append something into that catalog and say, okay, this package has been added or updated or deleted and so on. And then they run various jobs over that catalog. So when it appears in the catalog, you can run the package registrations, you can build that flat container index that they have, the actual search index, and so on. So they can use the catalog to pretty much feed all of the other APIs that they have. So that sounded interesting. If there's this append-only stream of all of the mutations on NuGet.org, can we, at JetBrains, also use this to see which packages show up on NuGet.org at a certain point in time? A bigger benefit even is that that entire stream is chronological. Everything is appended. There's a timestamp there, so if we want to have only the latest 5 minutes or the latest 1 hour, we can simply find the right resource and read from there. We don't have to read everything that is in there. We don't have to page through all the data if we were to reindex some things. The structure I'll quickly show you in the browser as well, is basically you have the root of that catalog. That catalog lists a number of pages, and every page points to registration or catalog leaves, which contain the actual package details. Very abstract, I know, but I'll quickly show you in the browser what it looks like. So this is the NuGet v3 API, and as I mentioned, what you will see there is a bunch of resources that you can access. So if you want to search, for example, you can see there's a search query service, we can follow that, and we can start using the search API. What's more interesting for us is that catalog that is in there. So if you search for that, you will see that there's a catalog URL that we can use as well. This is the interesting API for us. If we go into the catalog, you will see that that's a very simple index page. Highlight anyway, I'm fine with that. A very simple index page that contains items, and all of those items will be... I shouldn't have done the syntax highlighting. I'm going to refresh this one. The items are going to be links to those catalog pages. So this thing will just be, this page was added at this timestamp. That's what's going to be in those items. I really broke it now. Right. What do you do when something breaks? You restart. And even that is failing. Oh, damn it. Right. This is one of the golden rules in presenting something for an audience. You either try and struggle for 10 seconds, and if after 10 seconds things don't work, you go on and you will tell the audience, yeah, this actually works. So this actually works. All right, so you have the catalog index, you have those pages, and those pages have timestamps plus all of the package details that are available. Trust me, this works. Now, that JSON structure is something that we could read from code as well, so we could page over that entire catalog. But fortunately for us, since NuGet.org is also using this catalog for their own services, they have a library called NuGet.protocol catalog, very appropriate and also very original, that you can use to point to this catalog and see whatever is in there. So what we can do is make use of that library and do a couple of things. So first of all, what we want to do is create an HTTP client that we can work with. Second thing that we want to do is set a cursor. This catalog is a stream of events, a stream of data that is available, so we want to start reading it from a certain point. So if we say null, we read everything that is in there. If we say, for example, datetime_offset.utc now .add hours -2, we will get the packages from the last hour. Anyone here in the audience has uploaded a package in the last hour? No? Okay. It won't show up then. We have that cursor, and we can use that cursor to make use of a batch catalog processor. This is something that comes from that NuGet library that gives us access to the catalog. And what we're going to do is say, okay, I want to process whatever is in that catalog using a client, using that cursor that we have to basically set from where we want to read. And whenever a package is added, I want to execute this code. Whenever a package is deleted, I want to execute this code. So all of this is pretty much boilerplate what that NuGet library gives us. So what we can do is we can run this, and if we run the catalog dump, you will see all of the packages from the last 2 hours live streaming inside of my console there. So if you came here for the learning, I will learn you something. The Xamarin Rise plugin was uploaded at 8:35 this morning. Now you know. Right. Anyway, you get the idea. We have this stream of data. We have this stream of events coming from NuGet.org. And what we can do is react to that based on what their library holds. And we can do something with that, right? So whenever a package is added, we can react to it. Whenever a package is deleted, we can react to it as well. Why is there no package changed operation? Well, since NuGet decided that added is every mutation except the delete. So changed packages will also show up in the added callback that we get there. Right. So since the OData feed is disappearing, since it's not as performant as we would like it to be, we thought, well, should we refactor our existing find this type on NuGet.org in ReSharper to make use of this new v3 API? And we actually did that exercise. We have that running inside of a cloud service in web and worker roles, and that's basically whatever is still powering that search that we have in ReSharper. We were also thinking, since we have to make all of these changes, what would a more modern version of this look like? And that's the remainder of this talk. How could we build this thing using, for example, Azure Functions? We wanted to build a new version, and for that version to work, for that entire feature to work, we would need a couple of things. First of all, we would need something that watches the NuGet.org catalog for changes and deletes and whatever is happening there. For every change in a package that is on there, we want to download the package, unzip it, because a NuGet package is just a zip file, look at the assemblies that are in there, look at the public types that are in all of these assemblies, and then push that into a search index somewhere to keep a link between package ID and version, as well as public type and namespace. So that's what we want to do. Also, since there's a lot of ReSharper users out there, there's some still using various different versions, we didn't want to ship updates to the actual application. So what we also wanted was an API that is fully compatible with what is out right now. So we had to recreate that API as well using this entire new index. All of this is pretty straightforward if you think about it. Watching those changes can be a periodic check, polling that catalog and seeing whenever something happens on there. Every package change sounds kind of like a queue. We could emit all of the events that happen on that catalog into a queue somewhere and then have various processors pick up those changes and do something with that. And the API, of course, could be anything. Could be a HTTP function in Azure, could be a web app, could be a web API, whatever, as long as the thing would be always up and could have a flexible scale going from 0 users to a lot of users that could potentially hit that API. Sounds like functions, because in functions you have inputs, there's some processing happening, and there's outputs. I see a lot of people staring at me with reindeer eyes in headlights going like, what is this thing? This is an actual Microsoft marketing slide. You have input, processing, output. Great, every software works like this, I think. The more important things are underneath. That input is something that comes from a convention-based binding. You bind to a queue, you bind to an HTTP endpoint, you bind to a service bus queue or whatever, and that thing provides the input to your code. Your code then does something, but it doesn't have to care about where it should be writing that output. The code just passes along the output to the runtime of functions, and functions handles whatever the output is that is going on in there. Also, this entire flow is triggered by some event, and scale is also based on that event. So if there's no inputs, if there's no packages appearing, nothing will happen, and this thing can even scale down to 0 instances and not run at all, because there's no inputs. If there's a lot of packages coming in, if NuGet decides to re-sign every package that is on NuGet.org, well, we can scale up based on the number of events coming in. So this is actually really a very good fit for functions. And we started building functions. We have the catalog. We have one function looking at whatever is happening in that catalog. We enqueue the fact that we want to index that package. We also added a second queue to download the actual binary, so we have a copy of it for further analysis at some point if we want to. Both of those queues have their own functions listening to it. One to download the package, one to actually index the package and push it into Azure Search. And then once we have that, we can have an HTTP triggered function to basically provide the API into whatever data we have in Search. So let's start building that thing. Collecting from catalog should be relatively straightforward. We actually already built it in this program that I just showed you. What we can do is create a function that pretty much does the same thing. So what we can do is, in our type search thingy here, create a new timer trigger. Add that thing, call it IglooConf. There we go. We can add it, we can run it every 5 minutes, maybe every 15 minutes or whatever. We get a timer from the Azure Functions runtime, and then we can write our code, and I will do that in the quickest way possible. There we go, our code is there. Again, this code is roughly the same as what we had before, so it will give us the catalog client. We will follow a cursor, and for every package on there, I will log to the console, not yet push into a queue or whatever, just pretty much do the same thing that I had in that console application, but now as a function. I feel so modern. One difference here, though, is that instead of passing in a hard-coded date timestamp to that cursor, I get something for free from the Azure Functions runtime. I get this timer object, and in that timer object, there's a schedule status.lasts. So if I want to run this thing every 15 minutes, Azure Functions will actually give me the timestamp from 15 minutes ago, and I can incrementally index whatever is on there. If I have the last result, I can stop running, and 15 minutes from now, this thing will start again and continue where I left off the previous time this function ran. So pretty straightforward, just using that timer trigger and running it every 15 minutes. So let's run this one. And by the way, a very interesting thing coming up in terms of how you can debug your functions. So this function is now running. It will run every 15 minutes. So you can choose. Either we wait 15 minutes for it to kick off, or we trigger it. And I don't know if you knew this, but you can actually trigger every Azure function using either the get endpoint, if you have a HTTP-based function. But if you have something like a timer-triggered function or something like that, what you can do is post to your local functions runtime, /admin/functions, name of your function, pass it no data, and it will kick off the function, and the function will run. So just as a quick thing to learn here. So my function will run, and if we look at that, we will see an exception. Awesome. I know what I did wrong. So anyone know what I did wrong here in my logic? I get back the last time this thing ran, but if that last time is empty, if it didn't run before, it will always be empty, which means I will fall back to .utc now, but .utc now is now, which means unless someone uploads a package now, nothing's going to happen. So I have to also add that -2 hours there. So let's copy that over and add that there as well, just to be sure that we can show something. I know this is not the most exciting demo if you just look at the console outputs, but I want to prove that this works since I already had one demo fail on me before. Right, function is running. I'll trigger it again from my HTTP client there, go back there, and now you will see still that error message. Come on, this worked before. Might actually take a while to get the data from the, well, assume this works. Like I said, the 10-second rule, right? Oh man, this is going great. Why do you keep inviting me?
It's fun, man. Look at yourself.
All right. Yeah. So talk to Maarten. Right, let's go back to slides. At least I can do that, right? Good. So if you look at the function that I just wrote and that we all saw worked flawlessly, you saw that I was creating all of this infrastructure to basically get something from that catalog and then write something to console or push something into a queue. That's not super ideal. Ideally, our functions should be doing just one thing, or at least as few things as possible. And actually, Paul D. Johnston, anyone know that name? He's someone who worked at AWS doing all of the Lambda stuff there, so he's quite familiar with the entire functions and event-driven patterns. And he has a blog post detailing the function's best practices. And one of those best practices is that every function should be doing one thing, and only one thing, or ideally as few things as possible, because it makes it, first of all, easier to handle errors. If something breaks, you don't have to go through 50,000 lines of code. It's going to be just a couple of lines of code. Also, for scaling, if you want to scale just one small component of the application, you can do it independently without having to scale all of the functions that you have in there. Also, this does mean if you want to decouple things, if you want to work with smaller units of work in there, you will have to learn how to work with messages and queues and get this asynchronous messaging or communication happening between those functions. Now, that all sounds nice in theory. In practice, the Azure Functions team actually follows those guidelines. If you build your functions on Azure, you will know, you may have probably already seen, that there's a number of bindings that you can use in the application. In my example, that worked flawlessly again. We had a timer, and a timer will trigger the execution of a function. You can also have blob triggers and queue triggers, table triggers, and so on. They will trigger a function. Whenever something happens in one of those mechanisms, the function will start running. Additionally, you can have bindings that provide inputs. Remember the marketing slide that I showed earlier? You can have a function that gets its input from a binding. You can have a function that gets a blob reference or a message from a queue or a table record or whatever, and get that passed into your function. Same thing with output. Yes, you can write manually into a storage queue or into a message bus or a service bus queue, but ideally you just say, okay, functions runtime, I have these 5 messages for you. Can you please go ahead and add them into a service bus? There's one special trigger on here as well, and that's the HTTP trigger. What I like to think is a lot of people think that functions are really just for hosting APIs or just for hosting something that uses one of those bindings. I think they are the same. We are talking about message-driven or event-driven architectures on functions, and an HTTP request message coming in is just a message again. It only happens to come from a browser or another HTTP endpoint, but again, it's just a message that is triggering the function logic, doing something, and reporting something in a different outputs. Now, all of those bindings are there out of the box, but you can also build your own. I've seen on the internet Dropbox bindings where you can drop files on Dropbox. I've seen Christian Weyer, who has spoken here as well. He built a SQL Server binding where you can basically write a query, and whenever data shows up there, it will trigger your function and give you the data from your SQL database. The only binding that I feel is missing is a NuGet catalog binding. I would need that. So I decided, okay, let's maybe talk to Microsoft and ask if they can provide something like that. Wasn't going to happen. So had to think about writing my own. Now, this catalog binding should be something that triggers logic. Whenever we see something on that NuGet catalog, we want to trigger our function execution and do something with it. All of these custom bindings that you write are supported. If you create custom input or output bindings, they are supported by Microsoft. The documentation says, yes, you can do this, this will work. Custom trigger bindings, the documentation says this will not work. So that's an issue. Fortunately, we learned that it actually does work. There's only one thing that you should have, and that is that the instance of your, so the server that runs your serverless functions, has to be an always-on server. So it cannot be a consumption-based plan that you have. It has to be always running so that the trigger can run in the background and whenever something happens can invoke the functions that you have running. As long as you do that, in the more than half a year that we have had this thing running, we've only had our custom binding crash once or twice. So it's actually stable if you make sure that it's always running. With that, let's create a trigger binding. And you're in for a lot of code, and I hope this demo will work. Right, so we had all of those approaches, and ideally, instead of doing all of that, instead of doing all of this, where we have our catalog and we watch that catalog, and when the package is added, we want to add it into a queue and then do something with it. All of this code is way too much, actually. Ideally, we want to do something like this, where we have a function that gets triggered by a catalog trigger, and whenever we get information from there, we forward it into a queue and log the operation to the console. Now, to make sure that this thing actually works and that this demo will work, I will try and run this just to prove that this will actually work. There we go. So it's running. And we can see that packages are actually being added into our queues. So if I would look at my storage account that I have configured, I will see messages for every single package that was added into the catalog. So my binding works. That's great. First working demo. The thing I'm interested in now is looking at how we wrote that NuGet catalog trigger. What we do here is say, okay, I want to have a package operation be provided to the function that I have running. That package operation should be provided by this NuGet catalog trigger that uses a cursor blob name with the name of enqueuer. Remember that when we were reading that append-only catalog from NuGet, we had that cursor where we want to have a timestamp that keeps track of where we are in that stream of data that is in there. Well, this cursor blob name is where I want to store the data that we actually need to be able to know where we are in that catalog. So if I would look at our storage account there, look at the NuGet catalog trigger, there's a cursor, and if we open that one up, what's that again? Trust me, there's a timestamp in there. We'll do it that way. So that just holds a timestamp to be able to know where I am in that stream of data in that catalog, to be able to work with it later on. My catalog trigger itself is fairly simple because it's only a data attribute that provides some configuration options to the Azure Functions runtime. So our catalog trigger attribute is an attribute that has a service index URL, which catalog do we want to talk to. One where I can say previous hours equals 2, so that I can run on the previous 2 hours, for example. That has a connection to storage, and that has that cursor container and blob name where I will store that timestamp. This is all that there is in this attribute, just configuration values that I can either provide whenever I add that attribute into a function, or that I can hard code and have as a default. More interesting is that our catalog trigger attribute has an attribute itself called binding. This actually tells the Azure Functions runtime that the attribute denotes a binding, that we want to bind to some data based on whatever we have there, and that the runtime should be doing something to hook everything up and make it work. We have that binding there, and that's basically telling that. Now, if you would look at the documentation of Azure Functions, they would say if you have this and your actual trigger has the same naming conventions, all of this should work. That's a lie. The documentation should also state that you have to add a web job startup that also adds your binding as an extension. So I have to add a binding provider and an extension configuration provider there in that startup file, just like you would do in an ASP.NET Core application, for example, but you have to register it. Right. Now, I think we can all agree that this binding is not going to do a lot of things, and there should be more to this, right? I mean, it can't be that all of this is what makes the function work. So what we need is we have to write our own configuration provider. So if we have our catalog binding, what we have to do is create a configuration provider. And that configuration provider is going to follow naming conventions, so it has to be NuGet catalog trigger and then whatever config provider, but that thing has to be in the name. And what we do is when it initializes, when the functions runtime starts, we add a binding rule stating that whenever functions runtime, whenever you encounter this attribute that I created, bind it as a trigger binding to my trigger binding provider. That's what we do. This is basically on startup telling what the runtime should be doing with the attributes that it encounters. Now, of course, we need that trigger binding provider somewhere as well, and that's another one that we have. And also, this is, for some reasons, also naming based, so it has to be the exact same name as your attribute. So, pro tip here, don't make long attribute names, because every class will have a very long name. But this thing is actually where the logic starts. So we registered everything. If the function's runtime invokes my NuGet catalog trigger attribute binding provider, that's where the magic will start happening. What we do in here is when the function runtime creates this thing, we will look at the parameters we get. We check if the parameters are actually the attribute that we defined. Then we will do something with it. What we're going to do with it is set up a connection to a storage account, set up a connection to a blob client and to a cursor container so that I can already prepare that cursor blob that I will store with a timestamp on running over the entire catalog that we have. That's all we do here, initialize all of those things, and then we return a NuGet catalog trigger binding. This is the actual binding, finally. What our binding is going to do is take in whatever we constructed with, so that's that blob URL to where we want to store the cursor, and it's also going to create a listener for data. This thing is going to create a listener because it wants to trigger a function, so it also has to listen to some data to be able to invoke the functions that we have on the other side, right? So what it's going to do is create a NuGet catalog listener, and I'm going to dive into that one after this small break. It's going to do that. It's going to listen and invoke that thing, but it's also going to provide the data contract with the function's runtime. Is any one of you writing Node.js functions or different languages to C#? Yes. If you want to write a custom binding, you can do so. If you have a Node.js-based function, you can write your own custom bindings, except those bindings have to be written in C#. which means that you don't have the strong typed way of working with data that you have there. So what you will have to do in your custom binding is provide this binding data contract and tell the runtime what the shape of the data is. I'm going to say, look, I have data, which is going to be the raw JObject that I get from the catalog, but I also have a property called ID, version, published, package URL, listed, action, etc., so that if I have a Node.js function, I get a nice JSON formatted object with all of these properties. I know what type they are, and I can work with the data that I get from the functions runtime and from my custom binding. If you're doing just C#, you can forget about this and just pass along the data. But if you want to play nice, make it possible to use other languages as well, make sure you keep those around as well. Right, with that out of the way, let's go into our actual listener. Our listener itself takes whatever we initialized up till now, and what it's going to do is set up our entire catalog processor. Everything we had in our console application previously, instead of using an in-memory cursor, I'm now going to use a cloud blob cursor, which points to the blob that I am storing with the timestamp of where I am in the catalog. I'm going to create a catalog leave processor that will trigger a package added and package deleted function, and that's pretty much it. So my listener is going to do that, spin up this thing, and whenever it encounters data, it will call into one of these two methods. Those two methods are where the magic happens. Whenever a package is added, whenever we see something happening on the catalog, we will try and execute our trigger with data that contains the package ID, package version, published date, is listed, etc., and I'm going to try execute that on my executor. This line of code is the trigger. Whenever we invoke this in our binding, the function's runtime will trigger the function with the data that we provided. So whenever you see a package scrolling down in the log that I had previously, that is whenever this try execute async is run. Cool thing is, the Azure Functions runtime will make sure that this scales if you have multiple instances, that it's distributed and fanned out across instances and so on, but this is where the actual triggering happens. So yeah, that's it. Any questions on custom binding or custom trigger bindings there? Is it hard to debug these things? No, it's actually not. So we have our function that we have. So if we go back to our enqueuing function here, what I can do is place a breakpoint in there and see whenever data comes in. If I have something in my actual trigger, what I can do is go into that listener that we had, put a breakpoint, run through it, and I can see whatever is happening. So everything you expect to be able to do during a debug session will be available, and you'll be able to see what is going on internally, at least in the code that you are writing, to see what is happening in there. Hope that helps. Cool. All right. So yeah, that's our binding. Pretty nice. And instead of that big bulk of code, what we can now do is simply have that catalog trigger and then forward it into a queue. Does anyone find this strange? That I have something that triggers a function, that I'm enqueuing something, and then I'm having that queue trigger another function to actually do the work. Nobody finds that weird? It's not weird. The reason for that is our catalog is single instance, or at least the cursor that we have is single instance. We want to follow that entire stream, so ideally we can only have one reader on that catalog without having a lot of synchronization logic. So what we do is we have this NuGet catalog trigger that will run as a singleton, so there will always be just one instance of this function reading from the catalog, populating a queue, and from that queue I will start fanning out across multiple other functions that we have in the solution. Make sense? Cool. Right, we're making progress. We are watching the catalog, we have our queue being read and so on, and we can start working on the actual indexing and downloading of the packages that we have. So let's do that. And let's start with downloading the packages. Downloading the packages is going to listen to this queue collector that writes something into that indexing or downloading queue. And what the download is going to do is fairly straightforward. What it's going to do is, of course, be a function. My function will be triggered based on that queue that I was adding messages to. And whenever there's a message in there, I will check, is it an add operation or a delete operation? And based on that, I will either download the package from the internet and upload it into blob storage, or delete the blob. So not a very complex function, just doing 2 operations, but it makes sense to group them into one function for this purpose. Now, what I did want to mention here is that instead of setting up a connection to blob storage myself, what I'm doing here is making use of the output binding called blob. And my output binding is going to be a read-write blob using my downloads connection that I have, and it's going to provide me a reference to a blob that I can write to. So I don't have to care about read-write policies. I don't have to care about getting the connection to my storage account and so on. My function will get a blob, and I can simply write data into that blob. I don't even have to care about the name of that blob that I'm writing to. As you can see here, my blob path is going to contain the ID, the normalized version, and then ID and version normalized again, .nubkeg. This is going to be the file name of my function, where ID and version normalized are going to be replaced with what I get from my package operation. So I don't even have to care about that. The function's runtime is making sure that I can just write to that blob and push everything in there. So downloading, fairly straightforward, I think. We're done with that. Now let's talk about indexing packages. Indexing is going to be slightly more complex. Let's park the functions runtime for a while and look at how we can read from the packages that we get from NuGet. So I already mentioned that NuGet packages are zip files. And if you open them up, you will see a list of assemblies in there that you can read from and do whatever you want with. Now, if you were to build a solution like this, would you use reflection to load those assemblies? Imagine you are indexing 2 billion packages. You would not want to use reflection there. Reason is, everything is polluting your memory space. There's chances of all things going wrong, so you don't want to load those assemblies, but you still want to have the metadata that is in there. Turns out, since .NET Core, there's a nice package called System.Reflection.Metadata that you can use to open up a stream to an assembly and look at whatever is in there. It doesn't load the assembly into the process. Instead, it just enumerates over whatever metadata that is in there. Actually, an assembly in .NET, I don't know if anyone is familiar with this. An assembly has a header, the portable executable header, and in that header is all of the metadata that we could possibly need about the assembly that we are opening. So we can use that. Next thing we want to do is, once we have all the data from the assembly, is push all of that into a store that keeps the relation between package ID and version, plus the namespace and the type of the assembly. Could be Azure Search, could be a database, could be something else. We chose Azure Search, and we're diving into that in a little bit. Let's first talk about that System.Reflection metadata. If you open up your decompiler and open up any decompiled assembly in there, you will see that there's a metadata node in that decompiler, and that metadata node is that PE header that I just talked about. That is where you can see the metadata of everything that is inside of your assembly. You will see there's going to be strings in there, some blobs, some random data that .NET needs to be able to run your application, and there's also going to be a table called typedef. And that is the table containing all of the type definitions that we have in the assembly. And if you look into that one, you will see that this type definition with the pointer 2 has a name of bearer token connection. So that's a public type that is in there. Now that name was retrieved by following links, because that name is actually a pointer that is also in that metadata, and that pointer goes into the strings that we have in our assembly. So if we use System.Reflection.Metadata, we can start by reading from the type definitions, getting the pointer to the name, following that pointer, and then getting back the name from the assembly that we have there. I know, quite complex. I'll make it worse using some code. I have a PE reader there, which is coming from that System.Reflection metadata class. And what we do is enumerate the type definitions in the assembly that we just opened. For every type definition, we read the type definition namespace and name as a pointer. And then we use that getString method to actually get the data for that pointer, and then we can use that to index our class. You also see that if statement there. For the functionality that we're building with findThisType on NuGet.org, we don't care about display classes or compiler generated or statics or whatever that are generated. We just want the things that you as a developer will be using, so we filter those out in that loop, and we're not interested in following those. Make sense? Cool. Next thing we have is, once we have cracked all of those assemblies open and we have all of that metadata, what we want to do is push all that data into Search. Anyone used Azure Search or is using Azure Search? Anyone using Elasticsearch, Lucene? They're all roughly similar in the way that in that search as a service, which is Azure Search, you define an index. That index will hold documents, which is like in a database you have records, or in a table you have records, so you have an index with documents. And every document will have fields. Those fields can be searchable, they can be facetable, which means that you can sort of group them together. They can be filterable, which means that you can filter on the data that is in there. Makes sense with the name, right? They can be sortable, and they can be retrievable. All of these properties of a field in a search index have to be specified up front. You cannot change them when your index is already live. So if you are storing the package ID, but you didn't make it retrievable, there's no way for you to get the package ID out of that index again. So you have to think about what that data structure will look like up front, because if you want to change it, you have to re-index everything. So that's one of the downsides there. So think about what you want to search and what data you need in the API that we're going to build later on. And using that, we can start building the index that we have. So let's index our packages. 15 minutes left, which is a good thing. I can not show the demo, but just show the code, which is safer. Right, our indexer. We have our package indexer, and what our indexer is going to do is it's going to listen to our queue again with indexing operations that are coming in. We get package operations, which are in the shape of an ID, a version, published date, and all of that information. And using that, we want to start indexing. So what we can do in our function is create a client to the index that we want to work with, and then we can create a list of index actions, and at the end of our logic, submit all of those index actions into Azure Search and make sure the documents are available. I know this looks like not a lot of code, but it gets worse. If you go into the run add package async, this is where we index a newly added package. What we do is read our package from NuGet, store it on disk. I know, serverless, but we store it on the disk of our server. The reason for that is NuGet also has packages that are 500 megabytes in size, and I do not want 500 megabytes in memory. I do not. So that's why I'm storing them on disk in my serverless instance there. Storing it on disk, once we have that, we open up the package, the zip file that we have there. We get some metadata from the package, so package ID, package version, description, summary, all of that is in the metadata that NuGet provides. And we start creating a package document with that. Then we have the code that I just had on slides. We go through all of the assemblies that are in there and so on. And once we have all of the type names, we push them into our package that we want to index. And once we have that, we index it into Azure Functions. I know I skipped over a bit of code, but it's basically just making stuff work, so not that interesting. But suffice to say that we have the metadata, we push it into the index, and we also have the data we get from the assemblies, and we also push that into the index. Now the index, what does it look like? We have our package to index, and package to index is a package document. This is where we specify what the shape of our index is going to be. This is where we specify the fields that we have in the index. So our package document is going to have all of the properties that I just showed you in the slides. First of all, I want to have a primary key on my identifier that I have there. Package ID plus version is going to be my identifier. Why would you want a key in a search index? The reason for that is that we also have download counts to take into account at some point. And what we want to do is be able to update just that property. So if we have a primary key, we can sort of get the existing document, change that property, and store it again in the index. So that's why we want to have a primary key. Not required, but it can be useful for certain scenarios where you want to update data. My package ID is going to be searchable, of course, because I want to be able to search for a specific package. It's going to be sortable so that I can do some sorting operations on it as well. And it's also going to be retrievable. Since in ReSharper and since in Writer, I want to show the package that is going to be installed in your project, ideally, I want to show that package ID, so I have to make it retrievable. If I only want to search this field but never need the data to be shown in the UI, I could not make it retrievable. But again, think up front what you do with that document. So there's all of that. Some fields will be not retrievable, some fields will be retrievable, and some fields will have a specific analyzer. Anyone familiar with analyzers? Not a lot of people, so I'll quickly explain. Analyzers are basically a step right before your data goes into the index. An analyzer will run, and it will strip some unnecessary data from the fields that you are storing. If you want to store text into a search index, to search texts, has anyone ever been searching for a dot or a question mark or an exclamation mark? I don't think so. So most indexes are going to have an analyzer that automatically filters those things out, because for searching, you don't need that data. Now, since my type names will contain namespace dot something else dot type, that dot is actually significant, so I need that dot. So what I'm going to do is overwrite the default analyzer, pass in the simple analyzer name, and this is going to basically tell Lucene or Azure Search that I just want to store the raw data that I pass it, instead of stripping out the dots. This was interesting. After a couple of million packages, I realized that I forgot to do this, so I had to reindex again and again to make sure that I actually had the dots to search on. Anyway, back to our function. In our function, you see there's a lot of code, which also does the boilerplate thing, like getting a client to my search service, making sure that I have the index actions, then creating an index batch, pushing everything into Azure Search, making sure that if there's an exception, I handle the exception, and all of that information, or all of that boilerplate codes. And I feel that I don't really want that in my function. And if we think back to that rule of doing one thing and only one thing well, we should actually be moving all of that boilerplate code into another custom binding, so that we can just say, okay, Azure Functions runtime, I have this document I want you to index, use this binding, here you go. And have a custom binding handle all of the search stuff that we have in there. So let's look at that. 10 more minutes, we're totally fine on time. I have a version that uses a custom binding. And instead of having all of that boilerplate code that we had previously, what this function is going to do is it's going to still be triggered by the queue that we have. But instead of doing all of the Azure Search things manually, I'm going to have an output binding called Azure Search Index that uses a specific search service with a specific API key, a specific index name, a certain shape of index documents, and I want to merge or upload things into that index. And then have a document add collector. In my code, still a lot of code to do all of the extraction of the namespaces that we have, but in a sense, what this run add package async is going to do near the end is going to say, where is it? Document add collector, add this package that I want to index. Instead of doing all of those things manually, I'm just passing it on to the functions runtime and trusting it to trigger my, or use my output binding to store this thing into Azure Search. So let's go to our custom binding. Again, the binding attribute itself is not that interesting. It's just the data that I need for it to function, and I have to again annotate it with the binding attribute there. Also, don't forget, we have that startup class there. We also have to register our function as an extension. Don't forget this. And this thing is where the magic will start happening. We had this with our custom trigger binding as well. Now we need it for our Azure Search extension provider. But instead of adding a binding rule that triggers a function, this time I'm going to say, okay, for whenever you encounter the Azure Search index attribute, I want you to bind it into a collector. Collect data, push it into something. I'm going to bind it to a collector of type that provides the type OpenType, and that uses this Azure Search async collector builder. Quick note on this OpenType. I could build a custom output binding that just collects package documents for my use case, But I thought, okay, if I need to store stuff in an index, maybe I need to store stuff in a differently shaped index at a later point in time. Maybe someone wants to reuse this binding and use whatever shape of data they have. I want to be able to work with any type of index document, and that's where the open type comes in. It basically tells the runtime, give me whatever you want, and I'll figure it out and see what the shape of the object is. Since I'm using OpenType, I have to implement this Azure Search async collector builder, which is going to make the concrete type for my package documents that I have. So this is going to, under the hood, create a proper collector for the type that I want to work with. This collector is going to be much simpler. So trigger bindings, we needed the trigger binding, we needed the listener, we needed the configuration, and then execute something. This one is basically you have the attribute, the configuration, and then there's the binding. So we have our binding. And whenever the function's runtime wants to add data into the output binding that we have, it will call into add async. And in here, what we're going to do is index the item, make sure that if the index does not yet exist, I'm going to create it and then try re-indexing it just to handle all of those edge cases in that binding so that I, again, can have very clean code on the other side. Make sense? All right, cool. One more thing. We're almost there. We have the indexer, we have the catalog watcher, we have the downloading, and so on. All we now need is the actual find type API that ReSharper can use. So let's build that, and we can do that using an HTTP trigger binding. Again, I'm creating some sort of an API on Azure Functions, but think of this as an HTTP request message coming in, input, you doing something with it, and then providing output, which is going to be a JSON response that the API will return to the clients. So let's make this work with ReSharper and Writer. Not a lot of interesting things are going to be going on in there, so I'll quickly show you what our web API looks like. We have this find type API, and what it's going to do is listen as an HTTP trigger on a certain path. It's going to listen on a second path as well, because we also support searching by namespace. I'm going to close this one. And once we have that, we can run that search internally. So what are we going to do here? Fetch the parameters, which is basically what the API has to provide, and at some point, search in our index. One thing that I do want to mention here, because the indexing itself and the resulting and the formatting for ReSharper is not that interesting for every use case, but what is interesting here is the type of search that I'm doing. Remember that in our package document, we had this type names hash set with a simple analyzer. This is where all of the public types are in. So if I search for newtonsoft.json.jobject, that's going to be in this type names object inside of my index. Now, things like Lucene, for example, only supports one level of properties, whereas Azure Search allows you to have a document that also has a collection which can contain other types of data. So that's a difference there. And what I'm going to do is make use of the feature that allows you to search inside of those client properties or those sub-properties of your document. So what my search is going to look like is if I search for a type, I'm going to search in my type names columns for .typename, because that's going to be the last part of my string, newtonsoft.json.jobject. So I'm going to search for that. If I search for type name, I'm going to do the inverse. I'm going to search for the namespace dots. So if I search for newtonsoft.json.jobject, I don't care about the .jobject, but I'm still going to search for newtonsoft.json dot, just to get that data. Pass that into my search service, to Azure Search, collect the results, and so on. Anyway, believe me, this works, and I will actually show you this works. And this one will work, I promise. I can use it in the browser. So I have the API here. If I search for JObject or let's say JSON convert, popular thingy, I will get a result back, and my index will give me, there's a package called newtonsoft.json, where you can find the icon there. There's this amount of downloads, the description is in there, and your search matched the following assemblies and is available for the following platforms. And by the way, the explicit type was JSON convert in that namespace. So that's my API. If I now start ReSharper and I run it in the internal mode and I'm using a JObject that is not yet available in my project, what I can do is Alt-Enter, find this type on NuGet.org, ReSharper will start searching using my new API, will show me Newtonsoft.json, and I can start installing it from there and have the entire flow working. Right, trust me, that worked. One issue left, and that's one that we still haven't figured out how to do this properly, download counts. In a search index, you typically also want to include some relevance. If Zachary posts a NuGet package to NuGet that contains an object called, or a type called JObject, I want to be able to have Newtonsoft.json first and Saka second, or maybe even further down the list, because I'm probably after Newtonsoft.json, right? So I want to use download counts to provide that ranking and make sure that things are somewhere on top. Now, the downside is that currently the NuGet v3 API does not provide download counts. So I've opened an issue. I hope at some point they will see the third or fourth recording of this talk about me bitching about download counts, and they will start implementing that. Now, if the data existed, if there would be an API with download counts, I would update my index every day, every week, or whatever with those new download counts by using that key that I had in my package documents. I have my package ID and version. I can use that as a primary key and merge the download count in there using a merge operation in Azure Search. So I don't have to reindex every single object or reindex every single package. I can just update one existing package document. Right, we're done. The entire flow works. You've seen it works. I've actually searched in ReSharper and showed you it works. I do want to give you a couple of closing thoughts here. So everything works. We found that when we ran the last full index we did back in May 2019, we did it in 12 hours on 2 B1 instances on Azure. Anyone familiar with VM sizes will think that's a very low-level machine, and it actually is. It's a very slow and low resource machine, and it works perfectly. Only 12 hours to index all of NuGet. We can probably speed that up on bigger machines. We can probably make it faster if we scale out to more instances, but 2 B1s are, first of all, very cheap, and they do it perfectly fine, 12 hours to do a full index, whereas our current solution takes 2 weeks to do a full index. So 12 hours is awesome. We found that the NuGet.org homepage back in May last year was lying. They said 1.7 million NuGet packages available. There's actually 2.1 million available. We also found that there's 8,400 pages in the catalog with approximately 4.2 million catalog leaves, which makes sense if you think about it. 2.1 million packages in the index. They did the package signing at some point, which means every package is added again, so exactly double the amount of catalog leaves that are in there. I checked the index last week, I think. I found right now there's 2.6 million packages and roughly 3.5 terabytes of data in NuGet.org. If you want a copy, I can download it for you. Right, some closing thoughts on the functions approach here. You saw that we basically have a couple of roles. We have the package, the catalog watcher that watches the catalog. We have the actual indexing, and then we have the search. I would deploy all of those in separate function apps for a couple of reasons. First of all, for costs. Our watcher has to be running 24/7 on a reserved instance because it's a custom trigger binding, and it has to be online basically all of the time. It can be a small B1 instance, but it has to be running all of the time. The indexing can be consumption-based. Whenever there's no packages to index, I don't even want the indexer to run. Whenever there's packages coming in, they can spin up and they can scale independently. That's the third point, actually, scaling independently. If there's no packages, that can scale down to 0, whereas my API can scale independently from the indexer as well. Many requests, many HTTP endpoints, almost no requests, maybe very few capacity that is required there, or I can even use consumption and scale it down to virtually nothing. All of those things are also making it easier to monitor whatever the functions are doing, and yeah, you can basically keep things separate for cost and for fault domains. One note about bindings. If you care about vendor lock-in or framework lock-in, I would say, maybe it's not the best idea to use them if you want to move to OpenFaaS or whatever, use something more generic and do more things yourself. If you're all in with Azure Functions or web jobs, or you run web jobs in your own container, and it doesn't really matter that you're tying yourself into Azure, perfectly fine. Bindings are really nice to work with. Once you have them, your code becomes super clean, very reusable, and yeah, I would say go with them because the custom bindings really make it nice to work with. With that, thank you for being here, and yeah, talk to us if you have any questions. Find us and go ahead. Thanks.